Okay, today I want to introduce this idea to you, okay, known as the reductionist approach. Okay, it's a reductionist approach to math. Actually, what does reductionist mean? Okay, you can already tell the word reduce. Okay, it is a way of thinking. It is not any special formula. Okay, there's no particular formula. It's not even a particular theory. Okay, the reductionist approach is something that you can use for different subjects actually. Okay, so let me share with you what the reductionist approach is all about. Okay, so let's take a look at something that's totally not even related to math. Okay, so the Tower of London, you can see over here. All right, it's a very large building. I have stolen this portion from Wikipedia. Right, so you can see it's quite tall, 7 meters. 7 meters, that's similar to a 9-story building. A 9-story building today, it's not a big deal. But if you think about it, it was first built in the 11th century. Okay, 11th century are the years from year 1000 to 1100. That's the 11th century. And on the left, that's a typical accommodation that people would have had in the 11th century. So how come, okay, these ordinary folks, okay, why are they not able to build buildings for themselves that are as grand as the Tower of London? Okay, naturally, it's because they don't have enough money. Okay, now even if you give them enough money, okay, they will not be able to build something like the Tower of London. Okay, it's because can you see that their original huts, okay, were built on a different kind of foundation. Okay, they were made out of wood, they were made out of straw. Okay, the Tower of London is made of limestone blocks and bricks. Okay, so right down, okay, to the very basics, they are completely different. It would be a different matter, okay, if this guy, I presume is the owner of this hut, okay, he already had a stone hut built for himself. So if he had a stone hut built for himself, he knows how to build a stone hut. Okay, you give him enough money, he can build a palace for himself if he's rich enough. Okay, but right now, even if you give him all the money in the world, okay, maybe you might say he can hire somebody else, okay, to build it for him. That's right. Okay, but he himself, he will not be able to build it because he only knows how to make a wooden structure like this. So in understanding different subjects or different, even different areas of life, sometimes, I'm not saying all the time, sometimes it is very useful, okay, to have a reductionist approach. Go down to the very bare basics. What is it made of? Okay, reduce it to the simplest term. Okay, the simplest term, not literally, not like fractions. 4/8 equals 2/4 equals 1/2. No, not the simplest form. But if you are able to explain it, okay, to someone in primary school, say lower primary even, okay, that, okay, would mean that you have successfully reduced it to its bare minimum, so that when you are able to understand it in its skeletal structure, you will be able to understand it even if it appears to be very complex, clothed with many layers. All right, enough of all this background story. Okay. In fact, actually, you don't even need to know this, but it's good to know this. Let's take a look at an actual question, okay, that we can apply the reductionist approach. Change to a different color. or else I will keep seeing red color. It might put people in a bad mood. All right, so let's see. Okay, so if 2x equals to 3y, so we're supposed to find the ratio of x to y. Okay, it's a fairly simple question. Okay, so in other words, ratio, okay, can also be expressed as a fraction. X over y is literally x is to y. Okay, this is something that's actually taught in primary school. Okay, don't worry even if you have forgotten, because now you get a chance to revise. Okay? So if we can express it as a fraction, we will be able to express it as a ratio. Now, to express it as a fraction, okay, I need to get x on top and y below. In other words, I need to get, okay, x divided by y. There's a reason why the divide symbol is written like this. Correct. Why do we write the divide symbol this way? Why not some other symbol? Maybe your favorite car logo, or maybe M for McDonald's. So why do we write it this way? Because there's something on top and something below. Division is basically fraction. Now, I already have x over here. So if I move y over, okay, it will look like this. 2x divided by y equals to 3. You may ask, okay, how is this, what is the proof behind this? Okay, it looks very complex, but it actually really isn't. Let's take a look at this example. Say 6 equals, okay, 3 times what? So how are we able to get this? Okay, apologies. Let me swap their positions to mimic our question even better. Let me swap their positions. Okay, what? Okay, times. Okay, let me use 2 instead. See, there's a multiply by 2 over here. So if I move it over, realize that it becomes 6 divided by 2. Then get the number in the box, okay, which is 3. Something very basic that you've learned in primary school, but you can see that it applies even today. Okay, in other words, 3y is 3 times y times y. So I move to the left, it becomes divide by y. Now, this, I can write it as x over y times 2. Times 2, I'm moving to the other side. X over y equals to 3 divided by 2. Therefore, we have 3 is to 2. All right. This is actually the so-called standard way or normal way of doing such a question. If, say, you are completely stumped like this, what on earth is this? What does this mean? Okay, you can always try a reductionist approach. This is the question, right? Are you able to rewrite this question so it looks like something from primary school? Yes, we can. Okay, we need to have something times something, okay, equals to something times something, which is basically what we had earlier. 2x is something times something. 2x is 2 times x, what? Something times something. 3y is 3 times y, which is something times something. Let's fill in these 4 boxes. Okay, and bearing in mind that this is our so-called black box, and this is our oblique lines and horizontal lines. Okay, why do I do this? Okay, because can you see that this is supposed to represent our x, this is supposed to represent our y? So we want this to this. Okay, now we can start filling in our desired numbers. Try not to use 1. Use larger numbers. Say your favorite number is 5. Pick another favorite number, say 8. Okay, 5 times 8, 40. Okay, 40. Okay, so maybe this is 4, and maybe this is 10. Okay, so if I want to get these two to be together, so how do I do that? Okay, so you can see that this is times 4. So you can move over here, 5 divided by 4. This is times 8, and move it over there. Okay, 10 divided by 8. 5 divided by 4. Okay, if you press your calculator, 5 divided by 4, 1.25. If you press calculator for this, you also get 1.25. And 10, okay, it's our horizontal lines, okay, and 8 is our oblique lines. So we actually have the answer. 8 is to 10. So this is what I mean by reductionist approach. Okay, you change something that looks complicated, okay, break it down to its very bare basics. What is this? Something multiplied by something equals something multiplied by something. And all 4 of them have to be different numbers. So it is x, it is y. X cannot be y. One time, x, 2x basically means 2 times x. 3y means 3 times y. Okay, and they have to be the same. Yet all of them are different numbers. If you are able to put numbers inside and make them equal, you have successfully reduced it to its bare bones. You can use this same technique for all kinds of topics: trigo, vectors, coordinate geometry. Just reduce it to its very bare bones. What does it mean? I hope this has been useful.